Today, we're diving into the story of a secret code. Not just any code, but one that's written into the very fabric of the universe, and, more importantly, the story of the incredibly unlikely person who first cracked it. I mean, it sounds a little like science fiction, doesn't it? But this is the real deal. It's the true story of one of the most unexpected and, frankly, profound discoveries in the entire history of physics.
So, our story kicks off way back in the 19th century. There was this puzzle that had the best scientific minds of the day completely stumped. It was like a message, hidden in plain sight, just waiting inside a single beam of light.
Okay, so you know how when you shine light through a prism, you get that beautiful, full rainbow? Well, scientists expected something kind of similar when they looked at light coming off of superheated hydrogen gas. But that's not what they saw. Not at all. Instead of that smooth rainbow, they just saw 4 super sharp lines of color, a red, a blue-green, and 2 violets. That's it. It was a precise pattern, like a barcode, a message from the simplest atom in the universe. And the problem was, nobody had the key to decode it.
So you'd probably think some world-famous physicist at a top university is going to solve this, right? But the answer? Well, it came from a place nobody was even looking. And that brings us to our unlikely hero, a man named Johann Balmer. Now, he wasn't a physicist by trade. He looked at the world through a completely different lens.
And that quote really captures his entire worldview. See, Balmer wasn't your typical physicist looking for forces and particles. He was an architect by training. He was always searching for harmony, these beautiful underlying numerical patterns he believed connected everything, from buildings to music and, yeah, even to the stars.
And his background just makes this whole story even more remarkable. He was a math teacher at a girls' school. He published his masterpiece when he was 60 years old, and in his entire life, he only ever wrote 3 papers on physics. This was definitely not your typical scientific superstar.
So how did this teacher pull off what all the experts couldn't? Well, he started with just 4 simple measurements, but from them, he built a key that could unlock an infinite puzzle. And the result was, well, it was nothing short of incredible. This was it. This was all he had to work with. 4. Not pages and pages of data, just 4 numbers that represented the exact positions of those 4 lines of light. Just 4 lonely data points up against an infinite mystery. And what he did next was just astonishing. He found a single really elegant formula based on simple whole numbers, integers, that perfectly matched those 4 lines. But it did way more than that. His formula actually predicted there should be a 5th line, and a 6th, and in fact an entire infinite series of lines, all following this same perfect integer-based harmony. And how good was this prediction? Well, his formula was accurate to better than 99.9%. This wasn't some fluke or a close enough guess. It was a near-perfect description of reality, and he got it from just 4 data points.
Okay, this is my favorite part of the whole story. After he found the formula, Balmer shows it to a friend who happens to be a physics professor. And the friend tells him that astronomers had actually just found 12 more of these hydrogen lines in the light from distant stars. So Balmer checks them against his formula, and every single one fit perfectly.
Even Balmer himself was just blown away. He wrote that the agreement was, and I quote, surprising to the highest degree. He knew he had stumbled onto something really fundamental about how the universe was put together.
But here's the twist. Balmer had found a perfect answer. The big problem was, for the next 3 decades, nobody even knew what the question was.
His formula was so good, it became standard knowledge. I mean, physicists used it all the time, it was published in textbooks, even the Encyclopedia Britannica. But nobody had the faintest idea why it worked. Why did hydrogen atoms obey this one specific mathematical harmony? So you've got this period from 1885 all the way to 1913. For nearly 30 years, physics had this perfect, mysterious mathematical key, but there was no lock to put it in. It was like a ghost in the scientific machine. So who finally solved the mystery of Balmer's harmony? Well, the answer was going to require a complete revolution in how we understand reality itself.
The formula was absolutely right. But what did it all mean? The answer, it turns out, was just around the corner.
The hero of this final chapter is a name you've probably heard, Niels Bohr, one of the founding fathers of quantum mechanics.
And here it is. This is where it all finally clicks into place. In 1913, Niels Bohr imagined that electrons orbiting an atom weren't like planets. No, they were more like notes on a musical scale. They could only exist on specific, numbered energy levels, level 3, level 4, and so on. They couldn't be anywhere in between. And when an electron jumped from a higher level down to level 2, it released a specific color of light. A jump from 3 to 2 gave you the red line. From 4 to 2, the green one. 5 to 2, the violet. All of a sudden, Balmer's simple little integer formula made perfect sense. The math teacher's harmony wasn't just some neat pattern. It was the fundamental music of the quantum atom.
Just think about that for a second. A school teacher who was simply looking for harmony in the world uncovered a fundamental law of quantum mechanics 30 years before anyone even knew what quantum mechanics was. It just makes you wonder, what other profound patterns are out there, hidden in plain sight, just waiting for the right person to come along and see them?